Have you ever wondered why no two snowflakes are alike? Okay, picture this. You're outside on a freezing winter day, snowflakes landing on your sleeve.
Aha Doodles.
Each tiny flake starts as a water droplet freezing around an even tinier particle, called its nucleus, temperature, and humidity. They are the artists behind every snowflake's unique design. And as these crystals grow, they form stunning hexagonal structures. That's right, snowflakes have 6 sides because of how water molecules lock together when they freeze. At around 10 degrees C, water vapor in clouds condenses onto a nucleus, like a cosmic game of molecular Tetris. It could be a speck of dust, or something organic like pollen. This tiny nucleus is where the magic begins. Water vapor in the atmosphere starts to gather around the nucleus. But here's the twist, it doesn't freeze yet. Turns out, water can stay liquid below freezing point. It's called supercooling, liquid water hovering at icy temperatures. But as soon as the temperature drops even further, something amazing happens. The water freezes, and the first crystal forms, this hexagonal structure. It's all thanks to how water molecules bond. They stack perfectly, forming that 6-sided symmetry. From there, the snowflake starts its journey through the sky. Temperatures, humidity. They'll shape it into something truly unique. As the snowflake tumbles through the sky, something extraordinary starts happening. Its edges begin to branch out, almost like tree limbs reaching for sunlight. These branches don't grow randomly. They're sculpted by the air around the flake. Temperature, humidity, even tiny shifts in airflow play a role. Higher humidity. The flake grows faster, adding intricate patterns. Lower humidity. Growth slows, and the design stays simpler, steadier. And temperature. That's like the artist deciding between needle-like shapes, plates, or even columns. Each degree matters. It's a molecular masterpiece. Even the tiniest shift in conditions can make one snowflake's symmetry lean left, stretch longer, or spiral outward. Nature paints with precision. That's why no two snowflakes look alike. They are shaped by an unrepeatable dance of physics. Every one is its own icy fingerprint. Want to see the full magic? These branches aren't just pretty, they are electrostatic. Molecules pull together like magnets, building out those dazzling designs. But here's the wild part. No snowflake grows by a rigid recipe. Sure, it starts with that hexagonal base, but after that, chaos takes the wheel. As it tumbles through the atmosphere, each flake hits different patches of temperature and moisture. And every patch, a chance to change the shape. Humidity spikes. The branches stretch out wider. A sudden cold snap. They might pinch into tight plates. It's like the atmosphere is sculpting mid-flight. Here's what makes it even crazier. 2 flakes starting next to each other might end up looking nothing alike by the time they land. And this randomness, it's pure chaos theory. The idea that tiny changes, like one gust of wind, can lead to massive differences later. The exact shape of a snowflake depends on temperature and humidity during formation, kind of like how your Wi-Fi signal changes depending on where you stand. Japanese scientist Yukihiro Nakaya studied snowflakes in the 1930s, discovering their unique shapes are influenced by supercooling, like a freezer on turbo mode. Alright, picture this. Snowflakes aren't just chaos frozen in time, they are organized chaos. And turns out, there's a system to all that sparkle. Scientists have grouped snowflakes into 8 main types. You've got plates, columns, needles, and dendrites. Those iconic crystal stars everyone loves. Each type grows based on temperature and humidity, like how dendrites need the perfect frosty combo, around 5 degrees F. It's nature's snowy recipe. Now here's the wild part. Some flakes are simple, just thin plates, but others become full-blown masterpieces, branching out into dendrites. Snowflakes can grow up to 1 centimeter in diameter, forming intricate crystals within seconds, like a speed drawing contest in the sky. Meet Wilson Bentley, the Vermont farmer who photographed over 5,000 snowflakes, revealing their unique crystal structures. Each type tells a story. A needle might mean colder, drier air. A dendrite, high humidity. It's like reading a weather diary in the sky. Now, scientists like Librat use supercooled cameras to freeze snowflakes in midair, capturing their intricate dance of crystallization. Meet Kenneth Librat, the snowflake whisperer, who's captured over 10,000 unique snowflakes on camera. But what does snowflake research actually look like? Let's head to the University of Wisconsin-Madison, where science and snow collide in the coolest way possible. Here, physicist Kenneth Librat and his team study snowflakes like detectives unraveling mysterious clues, except they're magnifying glass. It's a high-speed camera. These cameras can capture snowflakes forming in real time. Imagine watching six-sided crystals bloom like icy fireworks, but caught in perfect, slow motion. This isn't just for show, though. By analyzing these images, scientists study how water molecules line up and freeze into hexagons. It's nanoscopic teamwork. They discovered that slight changes in humidity or temperature can send snowflakes down totally different growth paths. 1 degree here, a little moisture there. Huge results. Turns out, this research isn't just about admiring nature's artwork. It teaches us how crystal growth works in everything from ice to metals, and even your smartphone chip. So yeah, these scientists aren't just chasing snowflakes for fun. They are uncovering secrets that could one day shape how we design everything from bridges to batteries. So what makes snowflakes so unique? Why doesn't the sky send down perfect twins? It all begins with a supercooled water droplet, like a microscopic ball, floating around up there. Then it encounters a nucleus, like a molecular Lego brick, where water vapor condenses and freezes into a crystal lattice. That lattice starts flexing like a six-sided tick-tock dance, each arm sprouting identical moves because, surprise, every snowflake is a hexagon thanks to good ol' H2O's molecular shape. Now, scientists like Kenneth Librat have discovered that water vapor's temperature and humidity dictate a snowflake's final fancy form. Meet Kenneth Librat, a physicist who studied snowflakes and found that their unique shapes can have up to 6 sides or plates. So here's the answer. Each snowflake's unique shape is the result of its one-of-a-kind journey through the chaotic atmosphere. And next time one lands on your glove, just think, nature spent the whole sky making it special just for you.